So good morning everyone. So let us start today. Everyone has joined? Has everyone joined? Yeah,
Morning, sir.
yeah, good morning. So basically, in the last class, okay, in the last class we discussed regarding, I'm so sorry. In the last class, we were discussing regarding principle of superposition of forces. Yes or no?
Yes, sir.
Okay. So today we'll be discussing the topic moment of force about a point. Okay, so how to find out the moment and something about cross product and all. So shall we start?
Yes,
Uh,
sir.
if you can start.
Sir,
Okay, so let us start. Why so less students today? Everyone- Can you see my screen now? Yeah, can you see my screen?
No,
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 sir.
sir.
No. Wait. Wait a minute. Now is it possible? Is it visible?
No, sir.
No.
No.
It should be visible now.
It's now visible, sir.
Now
Visible.
it's visible, sir.
Now it's
Okay.
visible.
Okay. So now let us see about moment of force about a point by vector method. Okay, so that means what? If there is a vector, that means what? There will be both magnitude and direction. Yes or no? If there is both magnitude and direction, we will have that direction component also. Okay, so the moment, or for vector product, the moment is given by what? M equal to RA into F. Now, if you can see in the last class, we discussed about moment, right? Force force into D was moment. Last class, force into D, F into D was the moment. Now, but that was what? That was in the case of scalars. Now, if it is vectors, hmm, if it is vectors, then for being a vectors, what is important is we have to find out the vector product. Okay, so for finding out the vector product, the cross product RA. Look, in those case we had D, right? If we had D in that place, today this time we have R into A. R into A is what? R into A defines the position vector. Okay, R into A defines the position vector. Unlike in last class we had D now. So in place of D, this time R into A is present, which is basically the position vector. And force is what? F. It is denoted by F. Now, if you can see this hand here, so this is a right-handed rule. Now, if you can just take out your right hands and just check it in this manner. You put your middle finger, the index finger and the thumb, all three perpendicular in three mutually perpendicular axes. Then, okay, then the direction. Look, the direction is given by right hand rule, na? So then the direction of RA into F, RA into F, RA into F vector is given by your thumb. Then RA, RA, the position vector is given by your index finger, and the direction of your force is given by your middle finger. Okay, so this is how the direction is determined. Okay, so if in three-dimensional view, if you see here RA and here RA and this one F are in what? In ZY plane, Z and Y plane. But then in ZX plane, this is the moment. So this is how the moment is being determined. Okay. So moment of force is calculated in that manner in three-dimensional axis. Now in the last class, I explained you couple. I guess this one is clear with everyone. What is a couple? Now someone asked me in the first class or second class, I think so. What is a couple? So what does couple means? Couple means a system of parallel forces. So forces are what? Parallel. Look, this one and this one is what? These are parallel and in opposite directions. Pay attention to this. So if it is in opposite direction, this means what? This one is in this direction and this one is in this direction, right? If these two are in different directions, in opposite directions, then it is said to form a what? Then it is said to form a couple. Okay. So these two are in this figure. In this figure, it is for horizontal forces. Okay. The couple is formed by horizontal forces here. Now in this figure, what happens? The couple is formed by what? Inclined forces, right? So the couple is formed by inclined forces in this figure. Is it clear, everyone? Is it clear?
Yes, sir.
Yes? Okay, good. So now, okay, now let us go to another topic. Okay, let us go to another topic, which is resolution of a force. Now, in the last class, I taught you. In the last class, I taught you. Sound is not clear. Is it clear now? Is it clear now? Temazar,
Yes, sir.
it is clear or not clear?
Yes, sir.
Clear. Okay.
Yes, sir.
Okay.
It's clear.
So in the last class, what I taught you? In the last class, I taught you regarding this one, na? In the last one class, I taught you regarding how to resolve the forces into rectangular components. Now look, this is a brief explanation of that topic only. Okay. Now pay attention to this. Okay. Suppose a given force F can be resolved into two forces which together produces the same effects of that force. Again, sound not clear or what? Temazar?
Okay, sir.
Temazar? Sound clear or not clear?
It's clear, sir.
Okay, you gave messages now. So what happens? Look, a given force F, a given force F, it can be resolved into two forces which together produces the same effect of the force F. These are called the components of the force. Now this is the F, this is the main F force, okay, or this is the main F force. Now if you see here, last class we discussed no, like this. We discussed like this no. Suppose this is the force. Now if this is the main force F, then this force can be divided into two components, Fx and Fy, right? If these two forces are divided into two components, f of x and f of y, then these two, then this one and this one, if you combine these two forces, then it will come out to be what? F. Okay, this is what the basic concept is. Is it clear? So this is what the basic
Yes, sir.
concept
Yes,
is.
sir.
Now even in this figure, look, this is the main F, no? This is the main F. Now here one is f of x and one is f of y. So in this way, this is resolved into two components. Got it? So eventually we will be getting this. Now the value of f of x and how f of y. Okay, that sin theta cos theta will come now. Now look, this force F is making an angle. Is making an angle. Look at this. This is angle how much? This is angle theta, right? Now, if this is making an angle theta, then what will this be? Now look, if you see here this part, if you see here this part, what happens? Consider a force F acting on a particle O inclined at an angle theta as shown in figure. Now this one was inclined at an angle theta, right here. So what happens? Now let an x and y axis be two axes passing through O. Now if this is O, this is x axis and this is what? This is y axis, right? Now if this is x axis and this is y axis, then what happens? These two are perpendicular to each other, right? So these two axes are what it is called? These are called rectangular axis or coordinate axis. I guess everyone knows about it. Rectangular or coordinate. Why coordinate? Because in xy plane we denote everything in x and y now as coordinates. So this is basic thing. So this is how it is denoted. Now these two axes may be horizontal, vertical, or inclined. Look, this is horizontal and this is what? This is inclined. Therefore, the force can now be resolved into two components. What are those two components? F of x and f of y along the x and y axis. That is why along the x and y axis, and that is why these components are called what? These are called rectangular components. Now the two rectangular components of the force are, look, f of x equal to f of cos theta. That means what? In x-axis, this will be what? F cos theta, and in y-axis, f of y. We know discuss in the last class also this thing, no? So this is the explanation of that, notes of that. Are you getting me, everyone? Are you getting me, everyone,
Sir.
students? Yeah.
Yes, sir.
Yes, sir.
F of what? This will be f of sine theta. Is it clear, everyone? Is it clear?
Yes, sir.
Sir.
Okay. Okay. So this is how we resolve the components. Now, if it is in a three-dimensional thing, if this is in a three-dimensional thing, then we'll have all the vectors. This is a more complicated thing. So what you remember is just you can remember this one, these two equations, this one and this one. The last one is something matrix sort of thing. So this is a bit complicated. So let me tell you these things. Okay. So now look, in the last first thing we discussed that moment is what? RA into F. Now R. So R is the what? Position vector. So in position vector, what happens? If it is in three dimension, okay, if it is in three dimensions, so what happens? We'll have in the position vectors in all directions, na? So this will be X, this one here it will be one vector symbol, okay? X, Y, then Y, Z, and like this at K. And the force will be also in that direction, in same thing. I, J, J and K. Okay. So that means what? This moment expression, just you just think of the expression. This will be what? So for individual forces, it will be for individual moments in one direction. So it will be individual one. That means what? This one mxi. So if for in I direction, mij for j, mz k. Okay. So this is f is not there. Huh? F is mistake. So only mz is there. So basically, what happens here? So this is what the diagram in three dimension. So this is the thing. Okay, rectangular moment component. Just remember those two expressions. These are very important. This one and this one. Okay. Yeah. Did you understand, everyone? To this part. Yeah. Someone is making noise.
Yes,
Please
sir.
mute your mic. Someone's very irritating noise is coming. Did you get what I have taught? This one.
For me, it's okay, sir.
What about
Yes,
others?
sir.
What about others? Understood?
Yes, sir.
No problem
No
for me.
problem. Okay, only two have responded. I think so. Everyone has understood. That is why they are not responding. I think so. Everyone is clear. Just ask me for any doubt, or else I will move to the next part now. If you have any doubt, just ask me, or else I will move to the next part. Yeah, no one is having any doubts. Rohula Ansari, any doubt? Are you there, Ansari? I guess everyone is not attending the class. Yeah, Ansari is there, but he is not responding. What happened? Oh, no doubt, sir. Giving message. Okay, fine. So let us go to the next topic. Okay. So do you know what is a free body diagram? Does anyone know what is a free body diagram? Does anyone know what is a free body diagram?
No, sir.
No, no idea.
No, sir. No idea.
Okay, look, listen now. We'll just study that part. So, suppose can you see the presentation? Can you
No, sir.
No, sir.
No, sir.
no?
No, sir.
Now we
We
can
can
see.
see.
Yeah, it's not visible.
It is visible. Oliver, is
Yes,
it
sir. Now
visible?
we can
Yes,
see.
sir.
Okay, good.
Visible.
So now look.
Now it's visible.
Okay, so now have a look at this. So what is actually a free body diagram? Now in free body diagram, the isolated body from the structure, the isolated body from the structure of machinery or maybe any other object which shows all the forces and reactions forces acting on it. Now look, if you see here, this is a plank. You know what is a plank? Do you know what is a plank? Does anyone know? Do you know what is a plank?
No, sir.
Suppose it is a wood, piece of wood. Okay, got it? Suppose it is a piece of wood. Now another piece of log is hanging with another piece of log using this pulley. Now look, if this log, if you consider this log like this in a alone, that means these things are not there. Now what happens? We can see here, no? We can see here that a number of forces are acting on it, right? Because this is something, this is pulling from this side, right? This is pulling from this side. Why this is pulling? This is a pulley, na? So look, this is an y axis and this is an x axis. Now if this is an y axis and this is an y axis, x axis, so this is pulling from this side. That means what? It is giving some force T, that means tension. Okay. Now everybody has one normal reactions, and if everybody has some normal reaction, so the normal reaction always goes perpendicular from the body to above. So this is perpendicular from the body. Look at this. Its body is inclined a bit, na? So from here they have it is 90 degree. So it is 90 degree from here. So this is the normal component. Now if you pay attention here, so now if you pay attention here, this is what, this is the T force that is acting, and everybody has experienced certain mg means what? Mg is due to gravitational force. Now if mg is due to gravitational force, then what happens? if mg is due to gravitational force, so this gravitational force is always downward. That means it will be perpendicular to the horizontal axis. So this is the horizontal axis. So it will be perpendicular to this part. So it will be straight down. Okay. So that is why this is a bit in a different manner. Okay. So in this way, the mg and normal reactions are drawn. So basically, what is a free body diagram? Now, uh, this is for this, and similarly for this, what will be? Look, this is an object is in hanging position. Now this string is attached to it, so it will give some tension here. This is the tension and the gravity m1g. So m1g, why? Because m1 is the mass of this red, and m2g is why? Because m2 is the mass of this blue. So it will be downwards, na? So this is the basic thing. So in this way, this is coming downward. So these are all only the forces that is acting on this body. So what is basically a free body diagram? It means what? Suppose the forces are acting, a system of forces are acting on many bodies. Now, if you separate out each and every body from it, suppose this is one, here forces are acting, and this is another one. No? So, where forces are acting. If you separate this one and if you separate this one, then how much amount of forces are acting on each individual body? Suppose this one is one system of force and this one is other system of force. So how much force is actually acting in each individual system? This will define the free body diagram. So this is basically a free body diagram. Look, isolated body. The body is isolated. That means what? This is suppose a body. It is isolated from the structure of machinery or anything, which shows all the forces. So it is showing all the forces and reaction forces acting on it. So this is what we draw, do the free body diagram. So this is, we have isolated it and we drew all the free body diagram of this here. Okay, so in this way we drew the free body diagram. So this is the basic thing of free body diagram. Clear everyone? So suppose this man is hanging from this ladder. So here also there will be a free body diagram in this way. So here there are certain examples of free body diagram. In the previous slide, we discussed that one object was sliding now like this. Here object is sliding this now. So if this object is sliding, if you consider this person as the object, so what happens? Now these things, in this way the component will be resolved. Okay, this is just for illustration purposes and explanation. Okay, this is not that important for our study point of view. I'm just explaining it to you for our concept generation. Yeah, is it clear, everyone?
So,
Yes, sir.
Clear now? Okay, so this is how we determine the free body diagram. Okay, students. Hello, hello everyone, students.
Yes, sir.
Sir.
Okay,
Yes,
so
sir.
what I will do is I will give one numerical here. Okay, in the chat box the question is given, and I'll give you a diagram. You just click a screenshot of that diagram. Okay, and in the next class you just tell me the answer in the chat box. Okay, it is a numerical, na? Okay,
Okay, sir. Okay, sir.
I am typing the numerical in the chat box. So it will be more easier for you. Yes or no? So you just next
Sir.
class you just write the answer in the chat box. It is based on moment, and if you are not able to, we will solve it together. Okay, just tell me that you are not able to solve. You have to try it of your own. Okay, or else we will discuss in the next class. Is it clear, everyone?
Yes,
Yes,
sir.
sir.
Hmm. I am writing the question. Wait. So are you able to see the question? So are you able to see the question?
Yes, sir.
Okay. So now what I will do is I'll draw the diagram for it. You just click a screenshot of it. You can click a screenshot of the diagram now. Once you are I'm done drawing.
Yes, sir.
Uh, okay, good. Yes. Let's see if it is shared or not. Are you able to see a paint window?
Now we can see.
Yes, sir.
Yeah, please don't shout. This is the small square means what? This is a perpendicular symbol, okay? Draw a diagram, please, or click a screenshot of it. Okay, if you are. Is it clear, everyone? Is it clear, everyone?
Yes, sir.
So OB is how much? OB is 3 meter. Okay, this is O, this is B, na? So OB is 3 meter. Okay, and the angle is how much? 60 degree. The angle is how much? 60 degree. So, and P is given how much? 200 Newton. So can you find out the moment about O? Okay, you just try to find it out and show me the answer in the next class. Clear? Is it clear, everyone?
Yes, sir.
Have you clicked the
Yes.
screenshot?
Yes, already.
Huh?
Yes, sir.
Did you click the screenshot?
Yes,
Yes,
sir.
So I'm just explaining it to you again. Huh? Once more, this how it is. So this is a force of 200 Newton. This force is what? This force is acting at this point at an angle of what? At an angle of 60 degree, right? So this is the angle, right? Yes or no? And this distance between the point at which the force is acting, that means this point, and this point about which you have to find out the moment, it is how much? This is 3 meter. We just discussed moment today, na? So just solve it out. Okay, we have to solve it out and give me the answers. Will it? Okay.
Yeah.
Hmm. Then in the next class, I will give you another question. Then you can solve it. So are you? And this is, don't get confused with this. This is just 90 degree. This is 90 degree. That is why I am giving that perpendicular symbol. Okay, here it is 90 degree. That means, okay. Don't get confused with this. You know, na? I guess everyone knows it.
Sir.
Have you clicked the screenshot?
Yes, sir.
Okay. So write the answer in the chat box tomorrow. That means in the next class. When I have next class tomorrow, na? Tomorrow morning, I guess I have one class. So write the answer in the chat box.
9:15 to.
Yeah, 9:15, na? Okay. So you can give your attendance in the chat box. Shall I stop sharing the screen? Is it okay? Everyone, I'm asking, is it okay?
Yes, sir. Yes, sir. Can we leave, sir?
Hmm?
We have another class in 9:15.
Oh yeah, yeah. You can leave. You can leave. Thank you.